So number 3 was requested. From the top of the cliff, person throws the stone straight downwards. The initial speed of sound leaving the person's hand is 9.1 meters per second. So we know that, what's something we know right away about the stone? It's going straight downwards, that's good. And no, it doesn't start at 0. They tell us it's thrown downwards. It starts at 9.1 meters per second. It's at free fall. Yes. So we know right away, this is number 3, that it is moving downwards and in free fall. Now, what does it being in free fall tell us? What type of rate is that? You're right, that is it a position, a velocity, or an acceleration? It's an acceleration. Be careful, because when you say it falls at this rate, a lot of laymen, a lot of people that don't know really 100% what they're doing will think velocity. So make sure you use the word acceleration in there. But you're exactly right. So therefore, the acceleration is 9.80 meters per second squared down. So is this rock speeding up or slowing down as it travels? Speeding up, because its velocity is already down, right? And its acceleration is down. And when those two are in the same direction, you speed up. What if they're in opposite direction? Slows down. What if there's no acceleration? Stays the same. You guys are good. Can't trick you at all. Alright, so we know it's speeding up. We know it's... wait a minute. I think I just answered the first whole question. What's its magnitude? 9.80 meters per second squared. Which direction? Down. Part A done. Cool. Is the stone's speed increasing or decreasing? We said increasing. After 0.47 seconds, how far beneath the top of the cliff is the stone? Given the distance fall on that is magnitude. Also, they just want to know how far it's gone after this amount of time. So, I know how it starts. I know how fast it's going. I think I need to draw myself a picture just to help me organize my thoughts. Let's see. We have our funky little cliff here. We have our stone. I know it's moving downwards at 9.1 meters per second, but it's also accelerating down. Which direction do you guys want to call positive? Up? Okay. We'll call up positive. Now, personally, I probably would have picked down as positive, because if everything in my life in this is going down, now I got to deal with everything negative. So can we switch it? Is that okay? All right. That'll make me happy. Now, actually, it'll mean I probably mess up the math less because I don't have to deal with negative signs. What height do you guys want to call the top of the cliff at? 0 meters. That's a great choice, I think, because I like 0 to be where I start. And so after this time, this is going to move down, and we know speeding up the whole time, and it's going to end up like at this height here. What do you want to call that height? I'm going to call it, how about D? Is that okay? Yeah, I mean, we can pick anything. We call it bend, but D has less letters. Cockroach? Yeah, I messed up the spelling of that, though. So, I got to start here. Oh, I know my time is what? 0.47 seconds. I think that's right. 0.47 seconds. Good. And I want to know where it's at after this time. So I'm going to look at my equation sheet and say, one of these tells me a lot about where I am. So this one, this top one, tells me, hey, you're going to end up here. If you start here, you travel like this at the beginning, and then you accelerate like this while you're traveling. So this one tells me a lot about where I'm going to end up. And so that's the one I'm going to pick. What about this one? Well, this one says I end up going this fast because I started going this fast and I accelerated for a certain amount of time. I don't know how fast I end up going. I don't care how fast I end up going. I want to know where I am. And like this one says, hey, you end up going this fast. You started this fast and you accelerate for this distance that you travel. And again, I don't know how fast I end up going. I don't care. It would be a good extension to the problem, right? But so I'm going to grab this top one that tells me all about where I am. So now let's see. Let's put some values in here. So the D is where I end up. Oh, that's D. I labeled that D. That was convenient. Well, at what position do I start? I start at 0 meters. Plus, what's my velocity when I start? 9.1, and we said it's down, so it's positive 9.1 meters per second. I think I'm going to run out of room, so I'm going to move this all over. All right, and I'm blocking it a little bit. Times the amount of time I move for, which is 0.47 seconds, plus 1/2 my acceleration, which is down, so it's positive 9.80 meters per second squared, and my time, which is 0.47 seconds squared. Just a minute, Sam. Sean, I'm in the middle of something. Ah, number. So I can multiply those together, right? I can do my arithmetic. Let me see what I come up with. Here's my calculator. So let's see. 9.1 times 0.47. That's 4.277 plus 0.5 times 9.8 times 0.47. That 0.47 is squared. I get D equals 5.35941. So I'm going to put 5.3. Oops. Maybe I should put 5 first, not 3. 5.36 meters. Well, not 36. All right, we're going to do number 6. This time we'll actually get through it. So, in number 6, last time we talked about the Y, and the main points that we had here, and I'll write them in a second, is that the rock is in free fall. It goes from the top of the cliff to the bottom. But then when it gets down to the bottom, it creates this sound, which takes time for it to travel to the top of the cliff. All right? So it takes time for this rock that's in free fall to get to the bottom of the cliff, and then it takes even more time for the sound to get back up to the top of the cliff to be heard. So that's what I'm going to go along with. So 6. So rock in free fall. You guys okay with FF for free fall? Okay. And we'll even do capital. So acceleration is 9.80 meters per second squared down. If the rock is dropped, how fast is it moving at the beginning? 0. So dropped. So starts at 0 meters per second. And then big one here takes time for sound to come back up. So it takes time for the sound to come back up after it hits. So drawing pretty pictures. Got it. So drawing my pretty pictures. The rock is here. It goes down and hits. Boom. And then the sound takes time to come back up. So factors we know the rock starts at v equals 0. You guys okay with having 0 meters be down the bottom? Yeah? And the height of the cliff being marked as h? Yeah? Up or down is positive? Down? Down is positive. And we know that the rock accelerates down at little g, right? The sound doesn't accelerate. Sound just moves at a constant speed. And we could actually have that up here in our y. So this is at a constant speed. And when we talk about sound this spring, you'll find out why that's true. It has to do with the fact that it's a wave. So we have the time for the rock. That's the time it takes the rock to go from the top to the bottom of the cliff, plus the time for the sound will equal our total time. All right? So, if it takes 2 seconds for the rock to get down there and half a second for the sound to get back up, the whole time is going to take 2.5 seconds. All right? So we need to find the time the rock takes to hit, and then the amount of time for the sound to come back up. Or do we know that? Let's see what they tell us. We know the speed the sound goes at, right? Oh, and we know that the total time is 4.9 seconds, right? So, we know the time. We don't know much about the velocity except we start at 0 and the speed that the sound moves at. And we want to know about how high it is. And our equation that deals with time and all those factors is this top one here. All right? It's a lot of the time. I mean, you have your two definitions here of velocity and acceleration. The two down here are talking about how your velocity changes. And then this one talks about where you are. And a lot of times we're interested in where you are. So, yeah, a lot of times it is the go-to. For this section. I'm going to put this down here. And so I know this is 4.9 seconds, right? So I want to figure out how long, should I figure out how long it took the, well, I don't know. Let's see. Let's do this equation, but for the rock, okay? So for the rock, and we'll just do it for we'll do the rock over here. I'm going to push this up a little bit. For the rock, it ends up at 0 meters. It starts at h, right? Remember, it starts at the top of the cliff, which we called h. Its initial velocity is 0 meters per second, and this would be t rock, plus 1/2 positive 9.80 meters per second squared, because we called down positive, t rock squared. Yes? Did everyone see where I got everything I put in there? Yes? This is one of the tougher ones of the problems, to be honest with you. It really is. So, oh, what's 0 times T rock? 0. So can I just forget that that exists? Yeah. Huh? I don't know the time for the rock. I don't know how that 4.9 is broken up between the two of them. So if I rewrite this, I get, let's see, I get 0 equals h plus 1/2 times 9.80 meters per second squared T rock squared. Okay, so I have H and I have T in there. I can't really do anything, right? So let's look at the sounds now. This is why this is one of the trickier ones. We have to look at both sides. I'm going to use the same equation for my sound. My sound ends up at H. It started at 0 meters, plus it was moving at 340 meters per second for time T sound. Is that called sound? Plus 1/2. It's a constant, so 0 meters per second squared T sound squared. 340, yeah, it tells us in the problem. Speed of sound is 340 meters per second. And I know that it doesn't accelerate because I stated that in my Y. That was one of those things, extra information you may not have known right off the top of your head. Oh, what's 1/2 times 0? Times T squared. 0. I love it when complicated math expressions disappear. So I get that H equals 340 meters per second T sound. Could I rearrange that to solve for T sound? Yeah. Because now I have 3 equations. I'm going to rewrite the 3 equations to help you out, okay? You ready for the 3 equations that I have? I have that T rock plus T sound equals 4.9 seconds. I have, oh, wait a minute. Oh, here, I made a mistake up here, guys. You didn't even catch it. If down is positive, H should be negative. So I should have negative here and negative here. And I should have that, so I've got that, I'm going to bring the H over the other side. Is that okay with everyone? H equals 1/2 9.80 meters per second squared T rock squared, and I have H equals 340 meters per second T sound. I never got rid of the 1/2 up in the green. Right? I've summarized, I ended up with not being able to solve anything at the moment, but having 3 equations. I've got one that tells me, hey, the 2 sounds combined to be 4.9 seconds. Yeah. I've got one that tells me, here's the height as it relates to how long it took the rock. Can you see okay? And I've got the height that relates to the sound. And I want to solve for H. So I need to find one of these in terms of the other one. Oh, wait a minute. Which one? Yes, because it told me the whole time it's 4.9 seconds, right? Could be. Could be. Yep, right over there. I'm going to solve this one for T rock and this one for T sound, and then put them into that one. So this one, solve for T rock would equal the square root of, let's see, 1/2 on the other side would be 2. So 2h over 9.80 meters per second squared. And T sound would equal h divided by 340 meters per second. Yes? Oh, look. I have h by itself. How do I get the 1/2 over the other side? Multiply both sides by 2. How do I get the 9.8 on the other side? Divide. And then I got T rock squared, so I got square root. Here I've got h equals 340 times T sound. Divide both sides by 340. Now, I can do my final step. I can take these two and I can put these into here. Details about that will be to come. I wouldn't plan on failing at first test. This would be the toughest problem on the test if I gave it to you. All right? Yeah, but it would be the toughest one on the test. We got 2 days to review, don't forget. Yeah. So I'm going to put those in. I want to make sure we finish. So for T rock, I'm going to put in that. I'm going to put in square root of 2h over 9.80 meters per second squared plus h over 340 meters per second equals 4.9 seconds. How many variables do I have now? 1. That makes me happy. Sure, it's online. You can print one out, or there are in the top file drawer over there. I think there's only one left in there. So I have this nasty looking equation. Isn't it nasty? Yeah. You know what I do? I put it in the equation solver. You won't? What mean teacher would show you how to use it and not let you use it when you hit hard math problems? Uh-huh. This isn't math class, folks. The physics is, do you understand how to get to this point? Don't you? So, but this could be tricky to put in, right? I got to put in parentheses. 2 times h divided by 9.8. Close parentheses. And then I have to square root that. Caret 0.5. I think that'll work on this one. That's the weirdness, though. Let's see. Plus h over 340. Plus parentheses h divided by 340 equals 4.9. Thank you. Good. I'm glad you caught that. That looks right. Let's see if it interprets it how I want it to. Yes, it did. And so it tells me 100 and there's my height right there. Let's see. And what number is this? What number is this? 6. That seems right to me. Yes. And that is. So how would I write that with 3 sig figs? 103. So h would be 103 meters.